and today we are here to start the lecture series of Mathematics-02 Laplace Transform. Lecture 7 is depend on the Laplace transform of the periodic function. So we start from the periodic function. What is a periodic function? Periodic function is a function f of t is said to be a periodic if there exists a constant p greater than 0 such that f of t plus p equal to f of t for all value of t. If f of t is piecewise continuous periodic function with period p, then Laplace of f of t equal to 1 upon 1 minus e raised to minus ps integration 0 to infinite e raised to minus st f of t dt. Now it is Laplace of f of t. This is a definition of the Laplace. 0 to infinite integration e raised to minus st f of t dt. We are taking interval 0 to p and p to infinite. For the second interval, we are taking t equal to x plus p and dt equal to dx. For that, t equal to p, then x equal to 0. For t equal to infinity, x equal to infinity. Okay, so put the value all in second integral, we get as a first integral as it is. In the second integral, integration 0 to infinite e raised to minus s x plus p dx. Now e raised to minus sp is a constant with respect to x. So we take as a common integration 0 to infinite e raised to minus sx f of x dx. This is the noted as a Laplace transform. To find a Laplace f of t, we take this as a subject and we get the formula of the Laplace transform of the periodic function. Now, we are taking example to understand the periodic function. Find Laplace transform of f of t, where function is sin omega t 0 to pi by omega and in the second interval function is 0. What is the formula of the periodic function is Laplace of f of t is 1 upon 1 minus e raised to minus ps 0 to p e raised to minus st f of t dt. Okay. Now here p is 2 pi by omega. So Laplace of f of t equal to, we get 1 e raised to minus 2 pi by omega s 0 to 2 pi by omega e raised to minus st f of t dt. Now we divide the interval 1 minus e raised to 2 pi by omega s 0 to pi by omega e raised to minus st. Function is sin omega t dt. In the second interval, function is 0. Okay. So we have 1 e raised to minus 2 pi by omega s. Integration is e raised to minus st upon s square plus omega square minus s sin omega t minus omega cos omega t, and interval is 0 to, limit is 0 to pi by omega. 1 upon 1 minus e raised to minus 2 pi by omega s. Put the upper limit e raised to minus pi by omega s upon s square plus omega square minus s sin omega pi by omega, so it is sin pi minus omega cos pi. It is our upper limit minus lower limit 1 upon s square plus omega square minus s sin 0 0 cos 0 is 1. To solve this, we get 1 upon 1 minus e raised to minus 2 pi by omega s e raised to minus pi by omega s upon s square plus omega square minus omega minus 1 minus minus plus 1 upon omega upon s square plus omega square. Okay. So omega upon s square plus omega square is common. We take 1 plus e raised to minus pi by omega s, and for this we taking s square minus a square form, 1 plus e raised to minus pi by omega s and 1 minus e raised to minus pi by omega s, because this is a 2 pi by omega s. So we are taking s square minus a square form, s minus a, s plus a. This two formation is cut. So last answer is omega upon s square plus omega square 1 upon 1 minus e raised to minus pi by omega s. Okay, this is your answer of this example of the periodic function. We are revise this example again. First of all, you have to find what is your p. Okay, write the formula, put the value of p. If p interval here, then divide these interval formations. Now f of t is sin omega t in the interval 0 to pi by omega, and it is 0 to pi by omega to 2 pi by omega. Integration, we getting e raised to minus st upon s square plus omega square minus s sin omega t minus omega cos omega t 0 to pi by omega. Putting upper limit and lower limit, we get e raised to minus pi by omega s square plus omega square minus omega minus 1 plus omega upon s square plus omega square. Taking omega and omega square upon s square plus omega square common, we get 1 minus minus plus, so it is 1 plus e raised to minus pi by omega s, and 1 minus e raised to minus 2 pi by omega s, we are taking factor as a s square minus s square form. So it is s minus a, s plus a. So we are taking 1 plus e raised to minus pi by omega s, 1 minus e raised to minus pi by omega s. These two terms is eliminate. We get omega upon s square plus omega square into 1 upon 1 minus e raised to minus pi by omega s as the answer of this example. Thank you.